All right, cool. So here we go. Linear expression. So we're adding and subtracting linear expressions today. So the linear part of linear expressions, what word does linear kind of look like when you write it down?
Line.
Kind of looks like a line, right? So linear expressions are expressions where when you would graph them, they'll form a line. There are nonlinear expressions. In 7th grade, we focus on linear expressions. 8th grade in algebra, you'll be introduced to expressions, or equations that when you graph them, they would form other than a line. But for us, form a line. But what that really means is that the exponent for each variable is going to be 1, right? So that means that there's what? What's it say? So that means there's no exponents on the variables, right? So linear expressions are those that have no exponents on the variables. So what we're going to do is we're going to focus on just adding and subtracting linear expressions. What are the rules for adding? What's the rule for adding things? Exactly. So same sign, add, different sign, subtract, keep the sign of the bigger one so you can be exact. So really, when we add linear expressions, all we have to do is follow the rule, right? So what we want to do is recognize that there's a number in front of this parentheses. If you can't see it, what number is it? 1. What number is in front of this parentheses? There's an invisible 1, right? There's always going to be an invisible number in front of every parentheses, right? Because there's an invisible number in front of everything. If I have an X, how many X's do I have?
1.
If I have a Y, how many Y's do I have?
1.
If I have a cookie, how many cookies do I have?
1.
Good. If I have a set of parentheses, how many sets of parentheses do I have?
1.
Exactly. If I had a set of parentheses, so there's an invisible 1 here. What's 1 times any number? That stuff. So what's 1 times everything in here? That stuff. So what we can do is we can just, when we're adding, if we're adding these things, these expressions, so here's an expression, here's another expression, I want to add them, all I have to do is just rewrite it without the parentheses first. It's that straightforward, okay? So rewrite it without the parentheses. Negative 4y plus 3 plus 11y minus 5. Boom. And now I just need to use the shape method. All right, so circle all my y terms. Box my constants. Notice there's no spaces between my letters, or excuse me, between my shapes, right? I've included everything. And now all I do is use that shape method to combine my like terms. So negative 4y, positive 11, same sign, add. Different signs, subtract, and keep the sign of the bigger one so you can be exact. So it stays positive. Good, and then I do the exact same thing for negative 5 and positive 3, which gives me a negative 2. And that is my answer. So my answer is 7y minus 2. That's the sum. Why can I not combine these?
Because they're different terms.
They're not like terms, exactly. Good, they're different terms. That's it. Okay? Cool, give it a shot. Yeah, that's it. Give it a shot. Rewrite it without the parentheses. Use the shape method. That's adding. It's pretty straightforward. Give it a shot. I'm going to show answers periodically. I'll show the answers to number 1 in just a second. I want you to try it with your partner. Double check each other. Double check each other's work. There should be verbalization going on right now. Ready, set, and talk. Boom. Answer the first one's up there. So for your try-its.
Yes.
Good one. just write it without the parentheses? Like why is that a thing? Why can't we just write it without the parentheses? Yeah, Ashley?
Because the parentheses, you're not basing it off the parentheses, you're adding like terms. So 8z plus 4, you can't do that. You can do 8z plus 8.
Exactly. We're looking at the fact that this has an x in it and this has a 2x, so we can combine them. We can add those two. Adding is nice, right? We can add them. And keep in mind, there's an invisible 1 in front of those parentheses, right? Hey, look at number 2 now is up there. All right, ready? Here's the last one. Now, how else could this one have been written? Exactly, negative n plus 11. So what did you guys notice about number 2?
That you didn't put anything with z because they both canceled out.
They canceled out, yeah. One's positive, one's negative. That's called the additive inverse. Don't forget, that's called the additive inverse. And then on this one, notice how the order of the letters and numbers was different than what we've seen before? That shouldn't matter, right? The only thing that gets a little tricky is when you rewrite it without the parentheses. What happens to this double sign thing? Well, rather than rewriting this number without the parentheses, I thought it might be easier to put it in parentheses. Can you put anything in parentheses? You can put anything that's not being multiplied by something in parentheses. You can just put a parentheses around it. Like if I wanted to put a parentheses around this, parentheses 4.5 minus n, right? You can't just randomly put parentheses, but in this case it was just to identify that, hey, this is still negative. And you can do that. But if you think about it, you can even circle these. Why can't I just look at each individual term here? Because like Ashley said, we're focusing on the terms in the parentheses, right? Negative n plus negative 10. That's adding, right? That's an add wrap. It's an add wrap. So we can just focus on those two. Or here we can focus on those two. Okay? Questions on adding. Adding is pretty straightforward, right? There's not much to it. Subtracting, we have to do one step. What did we have to do when we subtracted integers? Keep, change. Change the size. We can keep the size and change. We gotta keep the number in the first place. Change the sign. So I want to change the subtraction to addition, but I can't just change the sign. Okay, I can't just do that. I also have to change each term in the parentheses, and that's in the second parentheses, right? So we want to keep, change, right? So here we go. Keep, change. The biggest mistake that people make is they don't change everything in the parentheses. Now, tomorrow we're going to learn about the distributive property. That's what we're doing here. Remember that invisible number in front of the parentheses?
Oh, yeah.
What is that? It's a 1. So this says negative 1 times this. So why are we changing the signs? Because we're actually multiplying by what? Negative 1. We're actually multiplying this entire parentheses by a negative 1. That's the math reason as to why we're doing what we're doing. There's actually an invisible 1 right here. And we're multiplying everything in here by negative 1. What happens when you multiply a number by negative 1? What happens to it?
It's a 1.
No.
It's that number.
It's what?
Nothing changes with the sign.
Nothing changes but the sign. When I multiply a number by negative 1, nothing changes but the sign. But if you keep this, the first parentheses, that's pretty easy. 5x plus 6. And now I need to change this to addition, right? When I do this, plus, and now I need to change everything in here too. So what am I writing down? Brenna?
Positive x plus 6.
Positive x
Plus
minus
oh,
6.
Oh, yeah.
Why minus?
No, you change it.
Yep,
So you change the addition to the subtraction.
yep. Change. Because guys, what am I really doing? I'm really multiplying it by negative 1, aren't I? That's the math behind this. The math behind this is I'm multiplying this by negative 1, and it becomes positive x. And then I'm multiplying this by negative 1 because it's in the set of parentheses, right? It's a grouping symbol. I'm multiplying everything in there by negative 1. And when you multiply by negative 1, Ashley reminded us that when you multiply anything by negative 1, what happens to it? It changes the sign. Nothing happens to the number other than that it changes its sign. It becomes negative or it becomes positive. So this becomes a positive x and this becomes a negative 6. And now we use the circle method or shape method to simplify and solve. So 5x and x gives us 6x. And positive 6 and negative 6 gives us 0, they cancel. So 6x is the answer to this problem. Questions? All right, talk them over with your partners, please. Talk over these two with your partner. Don't forget to do that keep, change, change method, and talk about why that keep, change, change method is effective. Right? It's because there's that negative 1 in front of it. Sing that song, keep, change, change.
Change the sound. What was that word?
I'll show you some intermediate steps as you go. You should be trying these. Guys, the only way you're going to learn this stuff is if you try them too. You have to try them. Okay? You have to. I'm going to be honest with you guys, as I do the shape method, when I do the circles, like I find the circles and then I combine them. Then I find the squares and then I combine them. It's just a little bit easier in my head. I don't do all the circles and all the shapes at once. I do find the circles, combine them. Find the squares, combine them. Guys, you should be talking about the changing that's happening with your partner. So did you guys keep, change each term in the second? Use the shape method. So when you're looking at these, why do we change this one? Because we're technically multiplying everything inside that parentheses by what? By negative 1. What happens when you multiply anything by negative 1? Yeah, the sign changes. So the first two terms inside the parentheses, they stay the same because we're not multiplying them by -1. What are we multiplying them by? There's an invisible what in front of this parentheses? There's an invisible what in front of that parentheses? There's an invisible 1. 1 times anything is that same thing. But in the second set of parentheses, there's an invisible 1, right? Anytime there's anything, there's always a 1 times it in front of it. So that's why the signs of the second one, you'll notice, are changed. Positive 6.3, negatives. And that only comes into place when we do what operation? Did we have to change anything when we did the addition? No. When do we do the keep, change stuff? When we subtract, okay? So notice that's the process. So guys, this is the work I expect to see in your notebook. I expect to see this problem written down, boom. Then you write it without parentheses, or with subtraction you keep, change. And then I expect to see the simplified version. Minimum of those 3 steps in your work today.